Hey everyone, welcome to part 4 of the ECS series, Entity Component System. It's been a while since my last update, and so, I'm sorry about that. I had other things that I wanted to kind of go and other requests and stuff, but this is probably my most requested series, so, I went back and decided to spend some quality time here and figure out the direction that I want to go in and how I want to set stuff up. Another piece of feedback that I got was that people had trouble reading the text on some of the videos. Some of them actually had it set to 100, which is not great. This is how I usually write code, but obviously no one can really see that. So I'm going to zoom it into 150 and let me know if that's better or not. We left off sort of defining some of the basic skeletal structure. We haven't really talked too much beyond this entity, and we haven't gone into too much about what's in the entity manager or how a component really is put together. So I think I want to demystify that a little bit and talk about how we want to do it. Unfortunately, it requires a pretty significant background in how general memory pooling and that kind of stuff works. So I might hand wave over that and then just talk about memory pools in general and go over, in great detail as to what a memory pool is and how you can implement one. I may save that for a different series. That's probably a couple of videos, right? The 2-3 videos right there. So in this, I'm going to just concentrate on some of the other stuff. So I'm going to refactor some of this stuff a little bit just to make stuff a little easier to look at. So first, let's just nail down what is an entity. Or how are entities stored? So the way that I want to store entities, so I want to store them as a hash map of type entity ID to entity. And I'm going to need, to basically hash this stuff. Entity ID. Well, all right, I'll do this in a second. But it's basically going to be this for now. Now, of course, because these are entities and full types, not pointers, I'm going to have to include entity.h. And then this guy should go away. Yeah, I'm going to set that up in a minute. This is part of what we're going to likely pool. But for now, let's just kind of define what these guys are going to be. So this is going to be a vector of vectors. So it's going to be basically 2 resizable arrays is a way to think about this. And these are going to be component pointers. And I'll talk about this in a minute because I know that might seem a little weird. Class component. I'll add this guy in here. I may need a full thing here. And so that should be, this is actually wrong, isn't it? Vector. There we go. So that's what components are. And then all the systems is going to be EASTL, vector of base component. I'm going to call it a base component system. Component system is probably fine. I'll leave the component system, it's fine. And so we're going to leave that kind of how it is. Now I can use these systems. I can start using this stuff. I'm going to move this just for fun. And then we'll have components as well. Components. And this is all components everywhere. This is every component that exists in the entire world, right? This is every single component. So this is the basic idea of what we're trying to do. Now I'm going to kind of step out here and reopen this guy. This is our old, our old kind of implementation of things. So we know that for components, we don't want to do sort of this sparse method or any of these kind of list-based methods. So the basic idea that I have, where's a good place to put this? Let's just put it over here. The basic idea that I have is I want to take, I'm going to have the first sort of axis of the array is going to look like this. This feels small. It's going to look like this. So it's going to be this, and then there may be kind of another one like this. Oops. And then maybe there's another one, you know, that looks like this. Maybe this guy has a lot, and so on. You know, there could be a whole bunch of these. So these are the actual components themselves, like arrays of components, and then these themselves are the actual like individual components. So you know they might be this big, and these are pointers for now, but bear with me. Maybe these guys are a little bigger, so they look like that, and maybe these guys are like this, right? So that you know we basically want something like this. And there's a few ways to get this. I made these smaller and smaller as I went on. That's fine. There's a few ways to get these. So, you know, this might be like, you know, transform. This might be, you know, AI. This might be render, whatever, right? So we want all of these guys to kind of line up like this. So that's the idea. And that's what we're looking for. That's why it's a 2D vector. So we have a vector kind of on both axes right here. So the reason why I want to do that is, you know, these are resizable. They're just as efficient mostly as regular vectors as long as you're not, you know, constantly adding stuff. So in this sort of outer axis, it's component. Use another color. It's component type or ID, whatever you want to call it. It's basically type. It's component type, going like this. So we can easily, if I have the component type, you know, transform, whatever, I can easily look up, okay, here are the different things. And then going this way, we have, you know, some kind of index going this way. So that I can easily, so if I have the index, so if the component type and the index, it's a super fast lookup, right? If I know that I am, you know, index like type, like type equals 2, and I know that, you know, index equals 3, then I know, you know, 0, 1, 2, and then 0, 1, 2, 3. I know that it's this guy. And I can do that super fast. And that's the plan. Now they're pointers, and we want them to be next to each other, right? This is a whole thing that I said when I, who knows where it is, in this giant thing. I may have, oh yeah, this guy, right? We didn't want this, where they're just sort of all over the place. And it seems like that's what we kind of have. But we don't. Because, while these are pointers, okay, so the problem with actually having pointers here is that whenever I call new, it's going to be like, well, here's my big block of memory. I'm going to take this guy, right? And I'm going to return it to you. And then I call new again. And it's going to say, okay, well, this memory looks good, right? So it's doing this sort of thing. But in C++, we can say no, right? We can overload new. Or override it, or do whatever we want. Like, we can have it do whatever we want. In our case, we're going to override it, and have it go do the thing that we feel like it needs to do. In this case, what I'm going to do is I'm going to use what's called a memory pool. So I'm going to kind of pull back up here and show you what that means. In essence, a memory pool, or a sort of pooled objects, is I'm going to say, okay, so let's say that I have some object here. We'll use transform. I'll do it like this. I'll say that I have some kind of vector 3. So that's going to be what, 24 bytes, right? Or what am I doing? 12. I know how to do math. This is going to be 12 bytes because it's probably 3 floats. And then I probably have some kind of, you know, rotation, which is probably another 12, depending on how you store it. I'm just, you know, we're just looking at a couple of possibilities, and maybe a scale, and maybe scale is like a uniform scale or something. So maybe it's just 4. So this gives us what, 28 bytes or so. Maybe we'll promote that to 32 so that it's sort of a bit more aligned. But let's say that's 32 bytes, something like this. What we could do is we could say, okay, cool. Let's allocate a bunch of 32 byte or 28, whatever you want to do. These are each 32 in size. Let's allocate a bunch of these chunks. And then whenever I ask you for one, you give me the next one. So this is new. This is our updated new. And then you give me the next one, and then the next one. So now things are nice and contiguous. That's what we want. Now, what happens if I have to remove one? Well, internally they're sort of managed as a list. So what ends up happening is you have a list where this guy points to this guy and so on. And then if this guy gets removed, we rewire these pointers so that the very next one allocated, this goes into some, free list. The very next thing that I have to allocate will come from this slot. So we're always filling up the stuff to the left as quickly as possible. I essentially have a queue of free spaces. And that's the idea. So as much as we can, we're going to fill this up. That's also why we get pointers in this particular case. It has one layer of dereferencing, but that's not a big deal. And the thing is maybe we won't even do that. For now, I think we will because it's easy. But we may not even do it this way. So important things to know. This whole array is pre-allocated. Now, what happens if we ask for too many? Well, there's two things that we can do. Number one, we can do what vector does, which is reallocate a whole bunch, right? So I have 32 times, what is this, 7? I don't actually even know what that is, although I should know this off the top of my head because it's power of 2. 224. So I have 224 bytes allocated here. What I could do is I could allocate, twice that. I could say, okay, let's allocate 448 and then copy, the first half of the array over and so on. And that's going to be dangerous because I have pointers here and all this other stuff. So that seems wrong. Other options are I could just store the index. I mean, there's a bunch of things that I can do, but I think that layer of indirection may not bias anything. I don't know what's going to be faster. I want to do more performance tests. I've done some performance tests on my plan, but I want to do more and see what's really the case here. For now, I think we're just going to do pointers because they're easy and because it should still be pretty efficient because the actual data is all going to be contiguous. So if we're looking, if we're essentially looping through all renderables, we should be able to crank through them. There shouldn't be too much trouble there. And we'll look at that at some point as well of how to iterate over, filtered components basically. And that's going to let us see kind of how we can kind of loop over, chunks of things and try and keep it efficient. I'm not convinced yet that it's going to be ever going to be perfect or even close to perfect, but it'll certainly be better than what we had before with just disparate blocks of memory just all over the place. Here, at least we have a nice thing. The other option, so we could do that. Option 2 is I allocate another block like this. Also 32 byte blocks. And, this is just a list. And then I go, and I point this guy down here and then keep going. So the advantage of this is that it's seamless and I'm only allocating another block. The disadvantage is that every time I have to jump to a new, for lack of a better term, page of pools, another block of pools, I'm screwed. I lose everything. In terms of cache, I lose everything in terms of cache. So that's going to be a cache miss. So few things. Is that something we can live with? It's something I feel like I can probably live with because the reality is you're probably going to tune the size of the pools per project and per game. That's what I do on my own projects. You might even tune it per level. You might try and auto-tune it in some way based on level data. There's a bunch of things you can do to optimize this even further, but I think at the very least it's a good starting point. So that's the plan. That's the idea. That's also why they're vectors, because they need to grow in size basically. So that's what we've got. Okay. Like I said, I'm not going to go super deep into the implementation of how pools work, but that's the basic idea, is that they're just a contiguous block of a bunch of memory that I slice up and divvy out. So it's size of component, basically, of whatever component is in here, of this component. So each of the pools is sort of its own thing. And we'll see how that all works in a minute. All right, I'm going to kill this because that's how components work, like that. All right. So now that we have this stuff kind of all set up, one thing that I feel like I want to be very explicit on is I want to be very explicit. So we're gonna have to entity manager. We're gonna have to have some kind of like construction. We're gonna have to have some kind of like destruction happening. But I want to be super explicit about these other things that we need. So C++ creates these magic functions for you. It creates the copy constructor and the copy assignment operator, the move constructor, and the move assignment operator, and also the default destructor and default constructor. And it creates them in certain instances. Like there's a whole bunch of rules. There's a book, which I feel like I've mentioned on various videos, possibly even in this series, by Scott Myers, called Effective Modern C++, and he goes over many of those rules. I think one of the other Effective C++ books does as well. So I'm actually going to say equals delete. This will make it so that it is not copyable or movable. I just don't want this thing moving around, and I think that's a reasonable statement to make. We have an initialization function. I think it's going to do one thing at this point, where I'm going to say create systems. I know the systems that I want. I'm not quite sure what this is going to look like in sort of a larger context, but this is where we're at right now. I want to be able to create entities, entity, and I need to be able to give it some set of components. So we'll look kind of at what this is going to look like in a minute. But I'm just going to kind of create a little bit of an interface here. So this feels about right for kind of our entity manager interface. So let's start looking at some of these guys. I think, do I have any of these created? No, I have literally nothing here created. So let's create some of these guys. This thing's gonna want to try and create all these deleted functions. There we go. Okay. Some of this stuff is gonna be sort of temporary stuff because I don't really want to integrate like TinyXML or some other data format. But I'm going to talk about how you could make it happen. So in this constructor, to do temp, create some test things. I'm not sure exactly how this is going to work yet. I do know that I'm going to want to basically go through and kill all of these components. I need to make sure that I go and destroy all these components. Create systems is going to create a bunch of new systems. Update. Yeah, I think the time is right now to start creating the actual components themselves. So I'm going to start with just the base component. So entity component is here. And so let's talk a little bit about what this is going to look like. As I said, this kind of thing is pooled. And so what we're going to do is we're going to say entity ID, and I don't know if I've actually defined entity ID yet. I probably have not. Do I have like a types thing? Yeah, I do. I have entity system types. Oh, I do. I have entity ID right here. And you even want me to include it. I don't want that. I want to include entity system types. Here we go. So in entity system types, so I have this entity ID. I have this pool index. Remember, if I go back out, where are you? This guy. If I go back out here, I need to know which of these pools it is. So you can think of it as an array of pools. So is it transform, AI, whatever. So it's going to have its own index, and that's what this says. Just because I probably am going to need it, we need to define what an invalid index is. And size t is an unsigned type. So I'm going to define it as numeric limits size t max, which means I'm going to define it as essentially max in, so it's, 0x ff. So that's the plan. This may not work as I think about it more. Maybe it will. My only problem is that it's going to be inconsistent on 64 and 32-bit mode. I may change what I do here. So one possibility is consider just using, u in 64 basically. But that's the thing to think about. Okay, so let's look at some of this other stuff. So I want a base component, and I want it to use an invalid entity ID. This is another thing that we should probably, define here, is what is an invalid entity ID. And for now, static const. So I don't need to be static. Const expression entity ID. I think for the sake of simplicity, I'm going to have it just be 0. So you're going to default to invalid entity ID. And then what I want to do is is that right? You're breaking on me. Okay. Maybe I just have to do this. I'm trying to figure out why IntelliSense is breaking on me. Oh, of course. That might help. Entity component. Okay, and then pool index is going to be invalid pool index. So we just have a little default constructor here. That should work pretty well. I've kind of already set up all this sort of stuff. This should be okay. So I want to be able to set the entity ID to some ID, right? So this should be, these are just kind of getters. I'm actually just going to copy and paste these for my little demo. These are just getters and setters. There's nothing super fancy about any of this stuff, except, should this be private? I don't know. I don't know that it's valid to set the entity ID at any given time. I think that might be like a private thing that someone has to kind of set up, like that someone has to be a friend in order to do. We'll see what that looks like too. This is a component. This is it. It's kind of all we need. All right, we've got renderable and we've got transform. So I'm just going to start filling this guy out. Public entity component. Usually there it goes. Okay. And this will probably be the last thing that we do. So there's a few things that we need to consider here. So we need a unique ID. And really, what we need most of all is we need a unique ID that sort of auto increments, because it's going to be an index, right? This is going to represent the index into this sort of this outer array. And there's a bunch of different ways to do this. The kind of classic way is we would have, in some other file somewhere, we would have, enum class, transform, whatever, right? And so we could do that, have this component types, and then here we would have transform, renderable, and so on, and then it would auto increment and all that stuff. But we'd have to modify this enum every time. Now, what we really want more than anything, I think, is something that just is never going to change. So what if we could just do it at compile time? Well, it's really kind of crazy. Oh, we don't have a component ID. Let's create our component ID. that'll work. Const expression, component ID. It turns out that you can do it. It's just, come on, it's just sort of nuts. Invalid component ID? I don't even know that I need this. I'll just do this. Unsigned int. Yeah, this is probably fine. Yeah, I don't know that I'm gonna need anything beyond that. So what we need is some kind of like magic here, right? To do it in compile time. And it turns out that you can. And I actually have a little thing that'll let me do it. Let's see, it's in Bleach Utils. What are we? Smart pointer. Compile time, auto ID. And the way that it works is you kind of do this like counter increment. And you have to give it some kind of, type. I'm going to actually go here and I'm going to say, you just have to give it something. This will give it a unique sort of name in the global namespace. So I'm going to say component auto counter ID or some kind, auto counter, ID. It doesn't even have to have anything. It's just something here. I actually probably don't even need to do this part. But we're going to increment this counter, and then here we're going to say counter read, and I'm going to say component auto counter ID. That's not what that's actually exactly what I want. And so this will create a nice constant time counter, and every time it encounters one of these things, every time it sees this sort of counter increment, as it's compiling, it'll add another value. One issue is that counter read actually starts with 1, so I'm actually going to do minus 1. So what that's going to do is it's going to give us a single thing. I'm actually considering putting this in some static or in some like const expression function so that it's super obvious. I wonder if that would actually work. Kind of just thought of this. What would it look like if I did this? Const expression component ID get next ID get next component ID. I'm not even sure that this is gonna work. Like, whoops. Yeah. Oh, that's not what I want. I feel like this is not gonna work. Be cool if it did, though. Yeah, I feel like this is not going to work. Well, let's see what it does. I wonder if I can make this work. Get next component ID. If I build this, I feel like it's going to explode on me. Oh, yeah. Stop. What are you complaining about? Yeah, that's what I thought. Whatever happens, this has to appear sort of a file scope. I was worried about that. Okay, that's fine. We'll do it this way. This is not super ideal, but it's fine. I don't like the -1 here, but we're good. I could change it, but I don't want to change the thing. It's a super clever way of doing this, and the code is very, very insane. Oops, that's not it. That's the runtime one. Where are you? Well, it's here. So it's like, it's all this, and I'm not going to go through this. I didn't write any of this at all. This was all found on Stack Overflow right here. I'll put the link to this article because I'm not going to go through the details of this. It's the C++ 11 version. I'll put the link to this in the video description. All the credit goes to whoever this is, Potato Swatter, it appears, and yeah. So that's basically it. And it's a copy and paste of that for the most part, with some very minor like name changes and using ESTL, that kind of thing. But I'll put the link to that article there. I'm just using that directly, but it's a compile time ID. In fact, I'm gonna make this public. So now, anyone can kind of look at transform component : ID and see exactly, which ID this is. It's gonna auto increment. It's all sorts of fun stuff. So, you know, we'll try and do something like, oops. We'll try and do something like that. Static const expression. Well, okay, so I'm gonna add some extra things like x, m, y, you know, maybe, I guess I have a vector type handy. So let's do that. Each use math. Where are you? There you are, vector. So we might say vector 3, you know, and position, whatever, right? Very simple. Position. What are you unhappy about? Oh, argument list. Right, we'll just do this. Vec3 is a type def for the float version of. So my vector 3 is a templated thing, so I can do whatever, I can use ints or whatever I want. So vec3 is the float version of it. Okay, you know, we might do like rotation or something like that. You know, it's like M rotation, or we might do, you know, quaternion or Euler angles or whatever you want to do. I'm just kind of, you know, uniform scale. It doesn't matter. Like, these are just values that we have here. So what I believe that we want here is we want transform component to, you know, sort of initialize these to something useful. M rotation is probably going to be 0. M uniform scale is probably going to be 1. And we'll let position sort of do its own thing. I don't need the destructor, but I am going to need, you know, virtual bool init override final for the fun of it. And this is of course going to take our void star p data, I think is what we called it. Description is what I called it. And, you know, again, this is going to be some like game specific, you know, XML or whatever it is. So, you know, you probably won't use a void star here. I don't actually know how I'm going to initialize these in this little like random test thing. So, you know, for now, it doesn't really matter. I'm just going to leave this here. But that's basically what we do. And there's one last thing that we need to do, which I'm not going to explain in significant detail right now. I'm going to include a thing called memory, where are you? Memory macros. And the way like I've created this whole memory pool system, you know, again, I'll probably go over it in a whole other video, but the way that I would do this is I'd say bleach memory pool declaration, and I would give it some value. It doesn't matter. I actually should probably rewrite this macro to where it doesn't matter, because it's going to be overwritten. But what this does is this does the actual declaration. So if I actually go to this, you can see that it will create some like static actual memory pool object. There's an init and a destroy that need to be called that will do the allocation and deallocation. And then it overrides the two forms of new and the two forms of delete. And so those are the things that it gives you. That's what this declaration does. And then what we need is we need a CPP file, which I don't have. I may do this in a different way, but it's probably fine for now. We're going to say transform component.cpp, transform component.h. And then in the CPP file, I need to also kind of do something here. Since I'm actually using it here, I have to use, you know, memory, where are you? There you are, memory pool. And then I basically say memory pool definition, and then the definition is just, you know, the type transform component, and then that's it. So then what this does, oh, not memory allocator, memory pool. There we go. No, not auto init. Why do you keep auto filling things in the wrong way? Definition. There we go. And then this guy, like, again, I'm not going to go into super great detail here, but we can kind of see what's going on. What it does is it will declare, will actually like define the memory pool itself, which of course it has to do. And then somewhere I'm going to have to call this a init memory pool, which is then going to actually allocate a new memory pool, and destroys it. And then new will allocate to the pool, free will free from the pool. And then, both of these guys will do the same thing. So that's the idea, that's the plan. And then, as I said before, with this init, it's going to create a whole bunch of these things, just allocate the memory and then construct in place as needed. That's the idea, that's the plan. Cool, so that's basically it. I mean, this is what a basic component looks like. So it has, and it could have a destructor, mine doesn't because there's nothing interesting here, right? But I could have some kind of destructor if I wanted to. Obviously, this would be virtual and override. I don't need one. This init will actually do the initialization, loading from data and all that stuff. And in my opinion, in the general sort of wisdom of this kind of stuff, that's it. Everything else is like naked data. It kind of breaks my C++ object-oriented head a little bit, but it's raw data that you can make changes to. Now, here's my general personal opinion. I don't think that any kind of data hiding is necessarily a bad thing. There are a lot of people who really believe that data hiding is bad. I don't happen to be one of them. I actually think it can be very good because if you have a bunch of engineers working in one project, it becomes pretty straightforward to make changes. Furthermore, changes can have side effects. For example, in my own system, I have this concept of, some movement happened, I may need to notify other things. Well, in ECS, you would actually just grab all the things that you need that could potentially be notified and notify them yourself. So I don't think I need that kind of stuff, but I can see the possibility of different side effects. For example, let's say that I didn't do this at all. Let's say that instead of this, I did this. Math, where are you? There you are. What if I wanted to represent my position as a matrix? Transform. Well, now it becomes a lot more lame and painful to manipulate this directly. So if this were the case, I might actually just hide this matrix behind sort of the private wall here, and then I might just create a bunch of getters and setters, right? I might just be like, okay, well, vec3, get pos, const, and then to be honest, like, I actually have like a get 2D, get 3D translation, for instance. Like, I can grab the translation. What are you angry about? Oh, that might help. And I can call set pos, but there's like side effects that need to happen, right? Like the way that a 3D matrix, works. If I'm going to pull this guy out and I do, 3D transform matrix or something. See if I can find a good image of what some of this looks like. Yeah, so like here's like building a rotation matrix. You can't just magically have this stuff like work. Like you can't just index into this thing. There's math that needs to happen in order for you to apply, rotations and this kind of stuff, right? Rotate about the X, Y, or Z axis. Well, you have to modify the matrix in some particular way. And so you're always kind of like multiplying stuff into like you can multiply various matrices and so on. My point being that sometimes you don't actually want the matrix. You want a series of functions that say get position, set position, get and set rotation, and so on. So I don't think data hiding is bad, and a lot of people who love ECS will talk about how basically these guys should just be structs. And I don't think that's the case. I don't, like, if I actually had, I think I went way too far here. If I actually did have something like this, I would, hold on, let me go back there. If I did have something like this, I think this is probably reasonable to have these be directly public. The only issue here is that I can't now have side effects for changing. Maybe I want to change rotation and it's supposed to, I don't know, play a sound every time rotation changes by 45 degrees. I mean, that's a horrible thing. Position is maybe a better thing where every time I change position, I want some other particular thing to happen. I want collision to trigger or whatever. There are cases where we want to have side effects to data being changed, or we want it to be changed only in very specific ways and within very specific constraints. For example, rotation might only be able to happen between negative pi and positive pi, or maybe it's 0 to 2 pi, or maybe it's 0 to 360. Like are these radians or degrees? And it doesn't have to matter. Because if I, probably this is actually going to be, likely I'm going to store these in radians, which can be a little annoying to work with. So, again, people are sort of against this, but why not set rotation degrees, right? And then it's just, you just set it, you just do the conversion right in here. Instead of having to do it in a bunch of different places. So I don't mind having these trivial getter, setter, utility functions. However, it can lead to the path of the dark side. And the path of the dark side is adding functionality, actual functionality. Because remember, oh God, where did I put it? Here it is. Components have no functionality, right? Systems have no state, components have no functionality. And that's really, really important because we're decoupling data from functionality. So if it's a data utility thing where it's literally data is set in this way or some really trivial convenience function or because I want to hide some complex representation of something, then I think those types of functions are good. The types of functions you'd consider basic accessors. But if it's like the thing that I described before where in my previous system, the transform component would send a message to all the other components and say, hey, I moved. If you care, then you should probably do something about that. That is much more of the system should do that. And so, you can get into some danger there. Okay. I think that's the end of my little kind of rant on that. This is the idea. I'm going to, I can do the exact same basic thing for renderable. All I have to do is, and I can even copy and paste this. This isn't going to work exactly, but for renderable, maybe I have some kind of texture, right? This is some memory that I have to deal with. So now I actually do have to have this thing going, right? I have to have some chunk of data here. I'll do it like this. Come on, unsigned character. This is just going to be raw bytes here, and so obviously all this stuff is going to change to null pointer or something, and maybe it's just this. Maybe this is the only thing I care about. It's just a texture, and then there'll probably be some geometry or whatever. But now, this stuff starts to matter because I have to destroy all this stuff, and so we've got these same kind of types of issues going on. But it's just a bit different. So here maybe I'll say MP texture equals new unsigned character. I don't know, 512 or something, just 512 bytes. I'm just throwing a number out here for fun. And then, here, of course, we would say delete MP texture, and then for fun, MP texture equals null. So we have this kind of stuff. Oh, I don't think I did this in here. Yeah, I didn't. So this is kind of what I mean. And then we can just write the components like this. And the only data, or the only functions here are these init sort of data setting functions, and it's just data. I can grab the texture right here. Here it is, and it's okay, unless I really need to hide it for some reason. Okay, so that's it. That's how components work. This is the idea behind them and all that kind of stuff. So this hopefully was enlightening and kind of how components should generally be built. Some of my philosophies on that stuff. The next major thing that we need to do, which we'll do in the next video, is work out how systems exactly are going to work. And they're not that tricky. They're actually very straightforward. So we're probably going to have time to do systems and then hook a bunch of stuff together, do a simple little test to make sure that I didn't break anything horribly. I should probably compile. And then the last thing that I think we need to do after that is I'm going to do a sort of a big test. I do have a bunch of compile errors. And it's just basic stuff, entity component ID and this kind of stuff. We'll fix all that kind of stuff next time. Yeah, we'll fix all this stuff next time. So I'm not too worried about this stuff. It's none of the stuff in the stuff that we've created though here. So yeah, that's what we'll do next time. Leave your comments. Let me know if you have any questions or anything like that. I'm going to try and get through the rest of these. I don't know how many videos there'll be. I'm suspecting maybe 2 more. And then we'll be done. So I'm going to try and actually crank through these because, you know, as I said, these are my highest requested videos. Okay, yeah, if you have any questions, let me know, and I will see you next time.